Hello everyone, and welcome to our video on completely solving a maximize problem using the Simplex method. So we actually did this in the very first video of this unit, but I think we can do it a little faster now, hopefully. So here is the whole process, the 8 steps. So it's a long process, but let's break it up. Let's do it. All the way down. That's the last problem I have on this sheet of paper. Hopefully that's good. All right, so let's see the whole thing done. All right, so our first step, so we are maximizing this subject to this. Our first step is to rewrite it so all the variables are on the left of our maximize function. So we would just subtract all the x, 1, 2, and 3 values on over. So negative 8x1 minus 10x2 minus 7x3. The z is still positive, so plus z because it didn't move anywhere. And then the right side would equal 0 if we subtracted all those x values on over. Okay, so that was our first step listed in the process. In our second step, we're looking at the inequalities. This bottom, well, I'm just going to scribble out. Those are the assumed things, so I don't really care about this. Here we have the main two. And in these two, we see, so that means if they did ask, hey, how many slack variables, we need to introduce 2 slack variables. So this top one, we would have x1 plus 3x2 plus 2x3 plus something. So plus this first slack variable needs to equal 10. And then this other one would be x1 plus 5x2 plus x3 plus a different something, so that's our second slack variable, would equal to 8. Okay, so these right here, this was our step 2, converting the inequalities into equations. Now that we have these two big steps done, now we can write it as a simplex tabla. So in our simplex tabla, so this is step 3, getting the simplex tabla ready. We've got, okay, so first let's see the variables, x1, x2, x3, s1, s2, and then z. So it looks like there's 6 things that are important to us. Let's go ahead and get that. So x1, x2, x3, and then there's an s1, there's an s2, there's a z, and then after that would be the constant. Okay, and it looks like there's 3 rows that would be important. Remember, this is our last row in these problems when we convert it, and then our starred ones, we could just kind of put in order first and second. Okay, so we've got, I think that would be enough room. So here's where the starred one go, the second starred, and then the last one. All right, so we've got, looking at the first star, I have 1, 3, 2, 1, 0, 0, and then the constant is 10. The second star, I have 1, 5, 1, 0, 1, 0, 8. And then the last one, let's get that horizontal line too to break it apart. Okay, so the last row is with the objective function, which is negative 8, negative 10, negative 7, 0, 0, 1, 0. Okay, so there's our setup. All right, so now that we have the simplex tableaus all ready, our fourth and fifth step were to get the pivot row and the pivot column. So I'm just going to say 4 and 5, and they usually, let me put it up here. So we will pivot. So they want to know the row and the column. But remember that the column is the thing that we would do first, and then the row is second. Okay, so the column is determined by the most negative in the bottom row. So the most negative is this negative 10. So I'm just going to kind of dot it, negative 10. So that means we are going to pivot column 2. So there's the answer. I'm just getting it ready. Okay, and then so I didn't want to make it too distracting because I don't want to rewrite this. I want to use this to help me get to the next step. But in this column, let me show the scratch work to the side, to the left. We're taking the constant on the far right and dividing it by the column entries. So on the first one, we would have 10 divided by 3 is 3.3. And then 8 divided by 5 that would be 1.6, and we could always use a calculator to help us. We have that 8 divided by 5, though, is 1.6. And so whichever one is the smaller one, 1.6 is, that tells us the row. So it is row 2 in this problem as well. Okay, so we will pivot. I'm just going to highlight it. We will pivot this whole row, and I'm just highlighting the actual elements. And then in the purple, let me go back and highlight it. Our goal when we pivot will be to change these two into zeros and apply row operations to all other elements to make sure that we convert it and do our math properly. Okay, so we've got our row and column, and now number 6 is to actually pivot. Okay, so 6, I'm just going to mark here, is the pivoting. When we pivot, I like to just go ahead and write out, let's write it right below it. I like to just have it set up blank still. Get everything kind of ready. And then the actual row that we're pivoting, so row 2 stays exactly the same. So let's write 1, 5, 1, 0, 1, 0, 8 there in the middle. Let me go ahead and get my one horizontal line as well. There we go. Okay, and then our goal, those underlined in the purple, those need to become zeros. So 0, 0. So there's just me kind of setting up my blank setup, I guess. All right, so to make those 0, though, we have to apply row operations using this pivot row. So this first row we'll say is, okay, so it's 3 and 5. Well, this is where we can multiply. Let's multiply the first row by 5 and subtract it by 3 in the second row. Okay, because they don't have anything in common, so that way we could just multiply the two together to make that happen. Okay, and then now that I have that set up, let's go ahead and fill these in. Okay, so we're looking at the first row and the second row. So I've got 5 minus 3 would be 2. And then we have 5 times 3 is 15, minus 3 times 5 is 15, so 15 minus 15 is 0. 5 times 2 is 10, minus 3 is 7. 5 times 1 is 5, minus 3 times 0 would be 0, so 5 minus 0 is 5. 5 times 0 is 0, minus 3 times 1, so negative 3. 0 and 0 is 0. And then we have 50 minus 24, so that would give us 26. Okay, so there it is. So again, I just try to do it in words. I think if you do it in Scratch work, that can be okay. It can get real messy. So I'm just trying to say it in words. All right, so that is our first row converted, though. Now let's do our third row. So we see it's negative 10 and 5 that are in common. Those are good. Okay, so let's just say, let's do row 3 plus 2 of those row 2s. That should do it. Okay, so and then going through it, we've got row 3 here is negative 8 plus 2 would be negative 6. Negative 10 plus 10 is 0. Negative 7 plus 2 would be negative 5. 0 plus 0 is 0. 0 plus 2 is 2. 1 plus 0 is 1. And then 0 plus 16 is 16. Okay, so we did all of our steps there with our arithmetic. It looks good, I hope. Again, I said this in another video. If we messed up, and we wouldn't know until we start entering answers into the computer, but if it says we're wrong, then I would just put a big old X through all of this and come back to it later. Because it is, if we know the process, then the mistakes are just something silly, like some arithmetic mistake. All right, so let's continue with it, though. So here we still see we have negatives in this bottom row. So we still have negative values. We keep pivoting until the bottom row is has nothing but non-negatives. Need all non-negative. So that means we're pivoting again. So step 7 is to repeat where we were, where we need to find our pivot. Okay, so 7. We are going to pivot a row and a column. Just to set it up. And still, the breakdown is the same, where I look at the column first. The most negative is right here in this bottom row. And then doing our quick arithmetic, the 26 divided by 2 would be 13. And then 8 divided by 1 is 8. So 8's smaller. So that means we will pivot our row 2. Okay, so this is the element right here. So we're pivoting row 2 again in this. Interesting. Okay, but that's how it was broken down. So let's do it. Okay, so from here. Okay, so I didn't write it in there in case they did want that. We are pivoting row 2, column 1. All right, so with that, same deal. Let's figure out what we need to do to pivot, and we can set it up just like we did before. That might not be enough room. Let me change that, where I just want to set up some blanks. Okay, so I've got x1, x2, x3, s1, s2, z, and then our constant. And then I think that would be enough room there. Okay, so this second row is the one that's getting pivoted, so that means it stays exactly the same. Like that. And then from here is where we can start to figure out the operations. Well, we can put those zeros in as well to make sure, hey, those should become 0 in this problem. And now let's see how it goes. All right, so we've got my operations to make that first row. Well, it's 2 and 1. So it looks like row 1 should become row 1 minus 2 row 2. I think that will do it. And then now let's do it. All right, so 2 minus 2 is 0. 0 minus 10 would be negative 10. 7 minus 2 would be 5. 5 minus 0 is 5. Here we've got negative 3 minus 2 would be negative 5. 0 minus 0 is still 0. 26 minus 16 would be 10. Okay, so there's that. And then now let's do it to our others, to our other row there. All right, row 3 needs to become, okay, so I'm looking at 1 and negative 6. Well, it looks like I should do row 3 plus 6 row 2. That should do it. All right, so now when we go through it, let's see. We've got negative 6 plus 6 is 0. Good. We've got 0 plus 5 times 6 would be 30. We've got negative 5 plus 6 would be positive 1. We've got 0 plus 0 is 0. We've got 2 plus 6 would be 8. And we've got 1 plus 0 is 1. And then last, we've got 16 plus 6 times 8. So that's where, again, this is where I try to save scratch work only when absolutely necessary. So that's 16 plus 48, which is 64. All right, so we've got 64. So 16 plus, yep. Okay, so there it is. Now that we have all non-negatives in this bottom row, we can read the solution. So we can get solution. Okay, and then the way that I look at it, I usually look at the non-zero stuff first. So right here, I've got a column with only one non-zero. And then over here, I've got a column with only one non-zero. And then over here, I've got a column with only one non-zero. So there's all of them. And then with that, we just set the coefficient with its variable. So right here, this would be 1x1 equals the far constant. So that one's already solved. We have 5s1 equals the far constant 10. And then from there, we could solve it. S1 would be 2. And then the bottom one, we have z equals the far constant 64. Okay. And then the other columns that have non-zero or have multiple non-zeros, so these three, mean that those variables are instantly set to be 0. So x2 is 0, x3 is 0, and then s2 is 0. And that's just by the rules of the simplex method. Okay, so now we do have everything. We have the answer. So we just put it in order. So x1 equals 8. X2 is 0. X3 is 0. S1 was over there. S1 is 2. S2 is 0. And then we got Z is 64. Okay, so there they all are. So what we just did, we did maximize our objective function. So the maximum, so when it might be like a word problem, we would say the maximum is 64 when all of those other things over there occur. So when x1 equals 8, x2 equals 0, x3 equals 0, S1, let me just erase that, S1 equals 2, and S2 equals 0. Okay, so that's it. Ideally, okay, so this is just an abstract problem. Ideally, we would want the x's to be non-zeros and the s's to be zeros because these were made-up variables that we had. So this slack variable means that whatever this 2 is representing for whatever it is in the problem is not actually being applied to the problem. It's just leftover junk. So we would want x's to be actual numbers in real-life applications. Okay, but that's still fine for this scenario. We do have it. Okay, so if you do have any questions, please let me know. But that is our giant process. So it's tricky. It's weird. But, I mean, practice makes perfect. Okay, so if you have questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.